What is the meaning of RSA is the reversed Shamir and Adelman. So this is how a RSA crypto system is going to encrypt as well as decrypt in the plain text. If it is more than 26, the P will be divided into blocks. Receiver chooses 7 and 11 as P and Q. Hello students, welcome to the next session of network security. Let's start this session. In this session, I'm going to explain you about one of the asymmetric key cryptography, that is the Rsa Cryptosystem. What does this Rsa Cryptosystem is all about? How it is going to encrypt as well as decrypt the code or decrypt the text in the Rsa Cryptosystem will be the concept that I'm going to explain. Let's start the session. The most common public key algorithm that we use is the Rsa Cryptosystem. What is the meaning of RSA is named after its inventors, that is the reversed Shamir and Adelman, or Alman can take. So combining the names of these three inventors, it is named as the Rsa Cryptosystem. Okay. How does the Rsa Cryptosystem is implementing the encryption and the decryption is, it is using the time complexity as well as the exponential complexity to calculate the encryption as well as the decryption. Here we have the complexity of operation in the Rsa Cryptosystem. So the RSA and cryptosystem uses two exponents, that is E and C. E represents the public key, whereas D represents the private key. Okay, E and D are combined to form a complexity, that is time complexity. Suppose P is the plain text and C is the cipher text. P is the plain text and C is the cipher text. You can calculate the C or the cipher text by using the E. C equals P to the power of E mod n you can use, and plain text can be calculated by using C to the power of D mod n. So you can use this expression to encrypt as well as decrypt in case of the Rsa crypto system. While they uses the polynomial complexity to calculate the encryption as well as the decryption. In case of Eve, to get the, even though she gets the public key and wants to get the plain text from it, the RSA uses the modular exponentiation for encryption and decryption. So it uses the modular exponentiation. That means polynomial complexity for encryption and decryption. To attack it, to attack the method, the Eve or the adversary needs to calculate the exponential complexity. That means P equals root of C to the base E with mod n must be calculated, which is not possible in case of the polynomial complexity. So, Eve will be failed in calculating the modular complexity and getting the plain text from the cipher text. When there is an invert operation that is possible, when it becomes to calculate the exponential complexity with the polynomial, it will become breached. The cipher text will be breached by the Eve. Till now, it was not possible to calculate or to get the cipher text by using the exponential complexity by the attacker. So, Rsa Cryptosystem ensures that the ciphertext will not be able to be decrypted by the attacker. Here we have the method of encryption, decryption and key generation in case of RSA cryptosystem. Okay, here we use the expression G equals, if you take as a function to generate a key, G equals Z of phi of n, which uses the total number of messages in the plain text. With this expression, it selects the P and Q values. N will be calculated by using P into Q and selects E and D, that is the private and the public key. E is the public key. It is generated or it is transmitted over the key transmission channel with the n number of values and is received by the Alice or the sender. She gets the public key and the number of variables in the key. So she can calculate the ciphertext by using P to the power of E, that is plain text to the power of E, that is the time complexity, exponential complexity with mod n. N is the number of characters in the message. Encryption will be done by using the expression R equals Z to the base n by additive inverse as well as the additive as well as multiplicative values will be used to encrypt, and the ciphertext is transmitted over the insecure channel. The receiver is going to receive the ciphertext and calculates the plain text by using the C to the power of D, that is the private key with mod n. Decryption will be R equals Z to the base n with the additive inverse and the multiplicative inverse. There we have normal additive key. Here we use inverse keys, additive inverse and the multiplicative inverse, and uses the expression to calculate the plain text by using the private key, that is the coefficient D is used here or the exponent D is used in this. Okay, so this is how a RSA cryptosystem is going to encrypt as well as decrypt in the plain text to calculate the ciphertext and from ciphertext to plain text. Okay, we use two algebraic structure to perform the encryption as well as the decryption. One is encryption and decryption ring is used. That means repeatedly same procedure is calculated to get the ciphertext. Z to the base n, Z as we said represents the base that needs to be used. Z, n represents the number of maximum characters, like we use English message in English language, it will be Z to the base 26 like this. So we use the additive and the multiplicative values to get the ring. For key generation group, we use G equals set of Z pi of n with the multiplicative inverse. We use the multiplicative inverse to calculate the key generation group. Okay. The RSA cryptosystem uses two algebraic structures. What are those structures is? One is the public ring with R equals Z to the base n and the additive and multiplicative values, and a private group G with the expression G equals Z to the base of pi of n and the multiplicative and additive inverse. So this will be using in the decryption. Okay, in RSA, the tuple E and n is the public key, whereas the integer D is the private key. Okay, so D is used with the ciphertext to get the plain text, whereas E and n, tuple E and n from the set are used as the public key to encrypt the plain text. Here we have the Rsa Key Generation Algorithm. In this, we will select two large primes, that is P and Q. We use the concept of primes. You know about the primes, isn't it? Such that P and Q will not be equal. There will be different primes that we use. N equals P into Q will be calculated. That is, N is total number of characters in the message. So we have the phi of N, P minus 1 into Q minus 1. Then we select the E, that is the public key, such that E is between the set of N and 1. Range of E will be 1 and N. And E is co-prime to phi of N. Okay, so it is a co-prime. D will be calculated by inverse of E mod phi N. So you are going to modulus operation with phi N with the inverse of E or the complement of E. Use the public key E comma N. So D is inverse of E modulo phi N. Whereas public key to be announced publicly, we have to publicly announce this E comma N, that is total number of characters in the message. Then private key is D. D can be calculated with inverse of E modulo phi N. So return the public key and the private key. Public key will be announced publicly and is transmitted over the key transmission channel or an insecure channel. Private key is kept for the receiver. When the ciphertext is received by the receiver, he uses the D value expression to calculate the ciphertext. Okay. So we use the Rsa encryption method. Anyone can send the message to the receiver by using the public key. That means we use the PEN. P is the plain text in Z to the base N. N is the total number of characters in that language, and P must be less than N. Plain text must be less than number of characters in the selected language. If it is greater than the number of characters, that is, if we have 26 characters in English, the plain text must have the characters less than 26. If it is more than 26, the P will be divided into blocks. Okay, and encryption algorithm is executed on number of blocks that is present in a plain text. Okay, so we use C equals ciphertext equals fast exponentiation, that is time complexity is used with the plain text, E value and total number of characters. So calculation will be P to the power of exponentiation E with mod N. Okay, then return the cipher text. In RSA, P and Q must be at least 512 bits. Okay, it has the range of key sets, and N must be at least 124 bits. That is 1 GB must be there. That is 1 gigabyte of memory must be reserved for N and 512 bits for P and Q. Okay. When you take the decryption algorithm, how does the decryption happens is decryption with ciphertext D and N. C is the ciphertext in Z to the base N. Z is the representing the number of characters in the particular language. Okay. Ciphertext D, comma N. So we have plain text calculated with fast exponentiation with C, D and N. Calculation will be C to the power of D mod N. It returns the plain text. Again, it uses the polynomial time complexity. Okay. It uses the polynomial time complexity. By using this expression, we can prove that the encryption and decryption in case of RSA are inverse of each other. If you take n equals p into q and a is less than n and k is an integer value we take, then a can be calculated by a mod n, a to the power of k into phi of n plus 1 will be equal with a mod n. So it is equivalent with the a of mod n. Okay. And the plain text equals c to the power of d mod n can be calculated as p to the power of e mod n to the power of d. That exponent d mod n will be equal to p e into d mod n. We use the exponentiation, the exponential time complexity. D and E are inverses of each other. So we use this expression to prove that encryption and decryption are inverse of each other. Okay, here we have the inverse expression. We use some trivial example or the basic example to calculate the plain text and the cipher text. Here we have the receiver. Receiver chooses 7 and 11 as P and Q and calculates the N as P into Q, that is 77. So what is the number of characters in the message is 77, or the language that we are using, it is having maximum of 77 characters. The value of phi n, how do you calculate phi n is p minus 1 into q minus 1, that is 7 minus 1 6 and 11 minus 1 10, 6 into 10 it is 60. So phi n has the value 60. Now the receiver chooses two exponents e and d from Z60. 60 is the phi n. So Z60 we take. Okay. If he chooses E to be 13, E exponent is 13, then D is 37. It is the inverse. Okay. 13 and 37 are the inverse. If you check the multiplicative inverse table, you will get to know that 37 is the multiplicative inverse of 13. We can note that E into D mod 60 will be 1. That means it is the multiplicative inverse of each other. They are inverse of each. Okay. Now imagine that the sender wants to send the plain text 5 to the receiver. Now the sender or the Alice wants to send a plain text 5 to the Bob. So he uses or she uses the public exponent 13 to encrypt 5. What is the expression? C equals 5 to the power of 13. That is 26 mod 77. So cipher text you get is 26. 5 to the power of 13. 26 mod 77, we get the cipher text 26. Whereas the receiver receives the cipher text 26 and uses the private key 37. So 13 was the public key, whereas 37 was the private key to decipher the cipher text. So now she uses, or the Bob uses, the receiver uses P equals 26 to the exponent of 37, that is 5 mod 77, which takes the value 5. So this is how an encryption and decryption can be done in the RSA crypto system. Now we have another example. Assume that another person, John, wants to send a message to Bob. Same is the receiver. Sender is different. Receiver is same, but the sender is different. John can use the same public key announced by the receiver. It is the 13, the public key it has used or the receiver has announced is 13. John's plain text is 63. So John calculates the 63 to the power of exponential 13, which takes the value 28 mod 77. So we get the ciphertext 28. Okay. So the Bob receives the ciphertext 28 and uses his private key 37 to decipher the ciphertext. 28, it is not 28 to the power of 37. It is the exponential of 28. 37 exponential of 28 gives you 63 mod 77. The plain text that is calculated is the 63. Okay. Now we have another example. We have another sender, Jennifer, creates a pair of keys for herself. She wants a response from the receiver. So she creates a pair of keys for herself. She chooses P, that is plain text, as 397 and Q as 401. She calculates N equals 1,59,197. She then calculates phi of n, that is p minus 1 into q minus 1, to be 1,58,400. She then chooses E as 343 and D as 12,007. Now, you can use it as an exercise to calculate the E and N. Okay, the solution is, suppose Ted is the receiver, wants to send the message no. Now, Jennifer is the receiver and Ted is the sender. If the Ted wants to send the message no to Jennifer, what it will do? He changes each character to a number from 00 to 25, with each character coded as 2 digits. Okay. He then concatenates the 2 coded characters and gets a 4-digit number. Okay. The plain text is 1314 we get. Okay. Concatenates 1314. Here we have a diagrammatic representation of the process. No will be having integer values 13 and 14. N is 13, O is 14. So it will be concatenated to get the value P equals 13, 14. 1314. We get the keys 343 and 1,59,197. So we use C equals 1,314 to the exponent of 343 mod 1,59,197. So we get the ciphertext value 33,677. So you can calculate it. Now it is sent over the insecure channel. When the Jennifer or the receiver receives this, she'll calculate the expression P equals 33,677 to the power of 12,007. That is the D value. It is the E value 343. 12,007 is the inverse of the 343, which gets the value D. So we calculate the plain text as 33,677 to the exponent of 12,007 mod 1,59,197. So calculates the plain text 1314. Now she separates the concatenated values 13 and 14 and it will be decoded 13 as N and 14 as O. This is how we can encrypt and decrypt in a RSA crypto system. In the next session, I'm going to tell you about the cryptanalysis of the RSA cryptosystem. How the RSA cryptosystem can be attacked, what are the possibilities of the attack in the RSA cryptosystem, and whether the RSA cryptosystem is vulnerable to the brute force attack or the plain text, non-plain text attack or only plain text attack. What kind of attack can be done on the RSA cryptosystem and how to get the probability of the attacks on the RSA cryptosystem. Okay. Thank you.